Welcome back to Hypnosphere. It is good to have you here. This is a quiet space for slow science, for curiosity that is never rushed, and for the soft, steady feeling that learning can bring at the end of the day. If you are listening in the evening, let the sound settle around you like a warm blanket. If your morning is just beginning, take it as a gentle light on your path. Wherever you are, whatever time the clock reads, you are part of a small, relaxed circle of people drifting together into wonder. Tonight we are going to Mars, not in the jolting way that rockets do, but with the careful, peaceful attention that asks what it would truly mean to live there. Not just to visit, wave a flag, and go, but to wake up again and again under a butterscotch sky, to make tea in low gravity, to listen to the air recyclers quietly working, to watch dust settle on a window, then brush it clean with a gloved hand, to build a life. If you like, you can imagine sharing where you are listening from, perhaps in a comment, and what time it is there. Not as a task, just as a way of marking a moment together. People on Earth connected across distance, thinking gently about another world. Mars is a small, cold planet that has loomed large in our story. It is close enough to touch with instruments and cameras, far enough to feel like myth. It spins a little slower than Earth, which means a day on Mars lasts about 24 hours and 39 minutes. It circles the sun at a greater distance, which means its year stretches to nearly 2 Earth years. It remembers a warmer past in dried riverbeds and mineral clues, but now it is crisp and thin, the air mostly carbon dioxide, the pressure less than 1% of Earth's. The light there is clean and tilted, a little weaker, about half of what we feel here, and colored by dust that paints the sky tawny at noon and blue at sunset. What would it take for humans to live in such a place? The answer does not arrive all at once. It gathers slowly, like condensation on a cool window, forming a picture from many small drops of understanding. It is a story of atmosphere and ice, of shelter and food, of power and patience. It is a story of what we bring with us and what we learn to use there. It is a story of limits, of the possibilities that fit inside them, and of the careful expansions that respectful craft can allow. Living on Mars begins with the simple, profound needs of our bodies: breathable air, drinkable water, safe pressure around us, protection from radiation, steady warmth, enough gravity to keep bones and hearts strong, light for our days and darkness for our sleep, food that nourishes more than our cells, food that tastes like a memory from home. And it includes needs we sometimes do not name: a view, a sense of belonging, a routine, moments of green in a landscape of red, voices that arrive, even if they arrive with a delay. To explore what it would take to meet those needs, we will wander through observation and experiment, through the past century of looking at Mars, and the present decade of building tools that practice on Earth for a life away from it. We will search for the quiet places where the science is already clear, and leave gentle room for the parts that we do not know yet. Along the way, we will hover with orbiters, land softly with rovers, and kneel in the dust beside small instruments making air grow from air. We will think about architecture that breathes, farms that recycle, and communities that learn to count time in sols instead of hours. None of this is a race. The universe does not hurry us. Mars rotates just the same whether we dream or sleep. The point is not urgency. It is care. It is making a space where a person could be safe and curious at the same time, where a child could laugh and a scientist could calibrate, where an elder could look up at a faint blue earth and hum a song. What would it take? That is the open question, and we will glide through it without rushing the answer. In the earliest days of telescopes, Mars was a shimmering disk with markings that seemed to shift and pulse. In the 19th century, some observers drew lines they called canals, and from those lines a story bloomed that said someone had built them. That story was wrong in detail, but it was right about something deep. It said that Mars lives in us as a mirror, a place where we practice imagining ourselves among the stars. Then, in the 20th century, the first spacecraft arrived and showed us a world with impact craters and ancient valleys, a world not currently alive with rivers, but not empty of history either. Between those two visions lies the patient work of truth. We will start there, at the beginning of seeing. We will walk from telescopes to flybys, from flybys to landers, and from landers to the steady hum of robotic geologists that have been driving for decades. With each step, the picture of living on Mars becomes less cloudy. It does not become easier, but it becomes clearer. Clarity is a kind of comfort. So settle in, breathe softly, and let your shoulders drop. Think of the small red dot that you have known since childhood, now as a place with weather and soil and ice beneath the surface. Think of a dome or a tunnel carved into ancient rock, with lights that bloom in the morning and dim at night, with people sleeping and waking, working and resting, while outside the wind traces long curls of dust and the sun glides lower than it does here. We will go there in our minds, and we will take careful notes. At the end, we will return to our warm rooms, carrying a little more understanding, and perhaps a quiet gratitude for the thin line that separates a planet we visit from a planet we call home. We begin, then, with the first careful attempts to understand what Mars is made of, and how those early glimpses guide the next steps toward living there. The old drawings, the first photographs, the first instruments that tasted the air, each one a small light leading to the next. When people first studied Mars through glass and patience, the eye did most of the work. The planet grew large for a few weeks, then receded again, and in that time, astronomers traced what they saw. In 1877, Giovanni Schiaparelli sketched fine lines he called canali, channels in Italian, and in translation, the word became canals, carrying with it the suggestion of intent. Percival Lowell spent years at the eyepiece, mapping and remapping a network he believed to be engineered. The maps were works of care, but the lines were an optical trick, born of contrast and wishful seeing. Even so, those images planted a seed that would grow into our curiosity about water and life. The first spacecraft peeled away the romance and replaced it with a quieter mystery. Mariner 4 flashed by in 1965, sending back a handful of grainy images that looked like the moon. Craters, a hard light, a silence that felt absolute. The first public reaction was disappointment, as if a dream had been taken away. But science is resilient. With Mariner 9 in 1971, a different Mars appeared. A dust storm cleared, and the camera looked down at immense canyons, ancient river channels, and volcanoes broader than entire countries. Valles Marineris sliced across the surface like a scar of geology, and Olympus Mons stood higher than 3 Mount Everests stacked together. Mars was not a twin of Earth, but it had been sculpted by forces that we understood from home. Wind, lava, water. Viking 1 and Viking 2 arrived in 1976, each with an orbiter and a lander. They touched down on rock-strewn plains. The landers stretched out robotic arms, sniffed and cooked samples of soil, and tried to see if something living might respond. The experiments gave mixed answers, some of which today are read as signatures of active chemistry rather than biology. Decades later, we would discover perchlorates in Martian regolith, reactive salts that can confuse a test designed for microbes. If the Viking landers puzzled us, that puzzlement helped shape a more careful approach. The lesson was that Mars has a story to tell about life, and that you must learn the grammar of its minerals before you ask living questions. In the 1990s and 2000s, the pattern of learning became steady. Mars Global Surveyor mapped the surface with patient precision. Mars Odyssey detected hydrogen just beneath the ground, a hint of widespread water ice in cold regions. The Phoenix lander arrived near the North Pole in 2008, scooped down, and saw bright chunks appear and vanish over a few sols as they sublimated. It was ice, water, locked cold but present. Not an ocean you could sail, but a reservoir you could gently tap. Then came the rovers that moved like thoughtful hikers. Spirit and Opportunity rolled to a stop on opposite sides of the planet in 2004, wrapped in airbags, then opened their eyes. Spirit worked in Gusev Crater and found volcanic rocks and altered minerals that hinted at water long ago. Opportunity found blueberries made of hematite, tiny spherules built by watery chemistry. It drove for years across Meridiani Planum, reading the layered pages of sediment like a slow book. When it finally fell silent after a global dust storm, it had traveled more than 45 kilometers, not as a machine racing for distance, but as a field geologist walking with intention. Curiosity landed in Gale Crater in 2012 with a sky crane that looked like a small miracle. It has been climbing the foothills of Mount Sharp ever since, drilling and analyzing, finding clays that form in water, cataloging organic molecules in the rocks, and measuring the radiation that falls from cosmic rays and solar events. This last piece matters for living on Mars. The rover's instrument called RAD has told us what a human body might absorb on the surface. It is not an easy number, but it is a workable one if you plan your shielding carefully and your time outside like a gardener watches weather. Perseverance touched down in Jezero Crater in 2021, in a place where a river once fanned into a delta and laid down sediments like delicate threads. It carries a small helicopter named Ingenuity that skipped like a dragonfly over the plain, demonstrating how flight behaves in a thin atmosphere. Perseverance drills cores, seals them, and tucks them away for a future mission to carry home. In its belly, it also carries a device called MOXIE, which quietly breathes in Martian air and makes oxygen from carbon dioxide. MOXIE is small, but it is more than a test. It is a kind of promise. It says that if you understand the chemistry of a place, you can make it slowly friendlier. Orbiters like Mars Reconnaissance Orbiter look down with cameras so sharp that they can see the tracks of rovers in the dust. They have mapped minerals that form only in water, found recurring dark streaks on slopes that may be seasonal flows of briny moisture, and traced the thickness of polar caps and water ice covered with dry ice that grows and shrinks with the seasons. Maven watches how the atmosphere slips away into space, and hears in the isotopes a story of a planet that lost its magnetic shield long ago, and with it the comfort of a thick sky. These are the early chapters of understanding, and they are quiet. No one solution for living on Mars is written in bold letters across them. Instead, there is a sense of sufficiency. Mars has what we need in scattered forms. Carbon dioxide for oxygen and fuel. Water ice for drinking, growing, and shielding. Minerals for building. A day not too far from our circadian rhythm. Gravity that is soft, but not nothing. You can almost see the outlines of a habitat in the data, something that tucks into the ground like a burrow, that wears dust like a robe, and that breathes with the help of machines that never sleep. Here on Earth, people have been practicing life support in sealed rooms. Closed ecological systems have been sketched, built, and improved. The lessons are practical and humbling. Plants should be partners, not decorations. Microbes will be your silent workforce. Air needs to be watched like a child. Water loves to run in circles. Humans thrive when there is a view, even if the view is a screen showing a familiar sky. If the early explorers of Mars once drew canals that were not there, the current explorers are drawing plumbing and wiring that will be, and testing it against the stubbornness of reality. As we leave this chapter of first seeing and first practicing, the picture of living on Mars grows more grounded. It is less about a city under glass and more about a village under soil. Less about replicating Earth and more about learning to cooperate with a different set of rules. The next step is to make those rules precise, to speak of pressures and doses and flows, of how many watts of sunlight fall on a panel at noon, and how many hours of battery carry you through a storm. We will move gently into that, and look at the physics of a day in the life. Imagine waking up on Mars. The night has been quiet. The pumps hummed, the fans whispered, and the scrubbers made carbon dioxide invisible. When you sit up, your body feels lighter, not weightless, but easier. Mars pulls with about 38% of Earth's gravity. You lift your feet to the floor and stand with a little bounce. In the habitat's morning, the lights rise slowly on a curve that mimics a dawn. Beyond a small window, the sky just beginning to pale looks dusty and soft. The air inside is at a pressure your body understands. Earth's sea level pressure is about 10-13 millibars. Mars outside sits around 6 or 7. Inside the habitat, you keep something closer to home, perhaps lower than sea level to reduce stress on the structure, but enough for lungs and thoughts to be comfortable. The walls are thick with layered materials. Aluminum or composite, insulation, and then meters of regolith piled over the top, or a tunnel carved into rock, or a dome of ice if your habitat sits near the pole. Above you is a roof that knows the sky. It slows down cosmic rays and the sharp particles that ride with solar storms. Curiosity's measurements suggest roughly 0.6 to 0.7 millisieverts per day on the surface if you stand unshielded. That can be shaped and softened. Live under soil, work with care, and let robots go where radiation is unkind. You move through a narrow corridor to the galley. Water flows from a small tap that remembers every drop. There is storage for reserves, tanks woven through the structure like a second skeleton. There are membranes that sip out impurities, filters that can be washed and replaced, and electrolyzers that can split water into oxygen and hydrogen when energy is abundant, then recombine them in fuel cells when you need power in the dark. In the corner sits a small unit that quietly burns Martian air through a ceramic heart to make oxygen. A descendant of Moxie scaled up. The oxygen turns a tank gentle green. The waste carbon monoxide becomes a feedstock for making other molecules. Outside, the world is cold. In equatorial afternoons, your thermometer might flirt with freezing, but nights drop far below. Mars does not hold its heat because its air is thin and because it has little water vapor to blanket the ground. The planet breathes carbon dioxide out of its poles when winter comes, laying down dry ice that later returns to the air in spring. A seasonal tide of atmosphere that rises and falls like a gentle chest. Dust devils wander the plains, sketching temporary calligraphy. Sometimes a regional dust storm spreads brown wings over thousands of kilometers. Rarely, nearly the whole planet wraps itself in lifted dust. Then the light dims for weeks, and habitats rely on what they saved for these moments, or on power that ignores weather. Energy is a cornerstone of life anywhere, and on Mars you gather it with awareness. Sunlight here is about 43% as strong as on Earth. Panels spread like petals on a patient plant. They tilt and track, and you brush them clean. During a storm, the sky can dim to a soft twilight even at noon. Batteries in the walls buffer daytime and night. Some places use small fission reactors, quiet boxes of constant power that make planning easier. In many designs, heat from any source becomes a treasure that is braided back into life support. The habitat is less like a house and more like a living engine, where waste is a rare word and loops are the rule. Food grows in rooms that smell like chlorophyll. If you expect to live here for years, you cannot import every calorie. You set up hydroponic racks or aeroponic frames and let nutrient mists tickle roots. The lights are efficient and glow with a balanced spectrum that keeps plants quick, but not manic. Leafy greens wave in a soft breeze that keeps their pores open. Tomatoes swell on trellises that climb toward white. Potatoes hide in fabric bags and take their time. You enrich the system with compost built from scraps, microbes, and a slow patience that turns peelings into fuel for growth. The Martian regolith outside is a valuable material for building, but it is not farmland in its raw state. It holds perchlorates and needs washing, or you keep soil as a carefully curated ecosystem that you brought and then expanded, adding local minerals after they have been cleaned. Nitrogen is a quiet challenge. On Earth, the sky is full of it. On Mars, the air carries only a whisper of nitrogen. You can find nitrates in the ground in some regions, and you can trap argon and nitrogen from the air as industrial gases. But your farms, your bacteria, and perhaps your pressurized spaces will ask for more. It becomes one of the reasons to choose a site with careful thought, perhaps a mid-latitude place where ice is not too deep and where the geology promises a mix of the elements that a biosphere needs. Time moves differently by a small amount. A soul is longer than a day by 39 minutes. Your body feels fine with that. Human circadian clocks often run a little long, and many people adjust easily. Some research suggests that when artificial light is managed gently, sleep can stay steady. Work schedules can add a breath here and there to stay in sync. Some habitats mark the Martian calendar with its longer seasons, watching the sun's higher and lower arcs and celebrating the first blue sunset after the return of winter. Movement outside is a ceremony. You dress for it in layers. A pressure garment, a life support backpack, gloves that let you feel your fingertips through softened plastic. The suit keeps you in an envelope of comfort, while the world outside holds at 1% of your inside pressure. A fall is gentle and low gravity, but never casual. The ground is grit on rock and sometimes slippery dust. Rovers squat nearby like patient animals ready to carry heavy things. When you walk, your steps are long and slow, and you learn a rhythm that puts no rush into anything. The sound is muted. On Mars, the thin air and its carbon dioxide composition carry high frequencies differently from low ones, so your voice, if heard outside, would be dulled and shifted. Inside, you speak at a normal volume and listen to the soft ventilators and the small clicks of instruments reporting their health. Over weeks and months, the rhythms settle. Data goes up to orbiters, then to Earth when the geometry is right. Messages to friends and family arrive 3 to 22 minutes after you send them, depending on the positions of the two planets. Conversations learn to be letters. There is a sweetness in that. People think before they speak, and answers are thoughtful. News from home comes in soft waves. News from the small community on Mars feels close, because it is. There is science woven through every day. Your greenhouse is also a lab. Your water system makes chemistry a companion. Outside, when you collect a rock, you are collecting time. Some are volcanic and young by Martian standards. Some are sedimentary and carry whispers of ancient lakes. You learn to read mineral names as moods. Clays mean quiet water. Sulfates can mean evaporation. Carbonates might mean gentle chemistry and time. In the evenings, you can sit at a small window and watch Phobos scud across the sky in a matter of hours, and Deimos go by more slowly. If a dust devil walks past, you see its slender body draw a line that ends where it began, leaving no harm. If the wind gets playful, you listen to it push softly against the habitat and feel grateful for every careful bolt. What would it take to live here? It takes this kind of everyday. Machines that breathe with you. Supplies that stretch because loops are closed and reused. Knowledge that turns carbon dioxide into oxygen and hydrogen, into water, and both into fuel. There is a chemical pathway called the Sabatier reaction. It takes hydrogen and carbon dioxide and yields methane and water. That methane could fuel a return trip. The water goes back to the loop. If you have hydrogen from water electrolysis, you can make the loop dance in time with your power budget. Even the exhalations of a greenhouse can feed your life support and your fuel plant, a small choreography of gases where nothing is lost. Think of a greenhouse on Mars as a kind of aquarium for air and light. On Earth, an aquarium holds a small world of water in balance. It filters and recycles. It hosts microbes that turn waste into nutrients. And it lets fish glide with the serene knowledge that their world is kept in a steady state. On Mars, a greenhouse would do the same for the atmosphere of a room. Carbon dioxide, water vapor, oxygen, and trace gases would move in gentle cycles. Leaves would breathe, exhale moisture, and drink photons. Roots would engage in quiet barter with bacteria at their tips, exchanging sugars for minerals. Human breath would join the circle. The walls would keep the outside out and the inside alive, like glass that grows. Biosphere experiments on Earth, including long projects where people lived inside sealed habitats, taught us that balance is an art. In some trials, oxygen levels gradually declined as microbes in soil consumed it faster than plants returned it. In others, unexpected chemistry in building materials absorbed gases. The lesson is not discouragement, it is calibration. On Mars, such a greenhouse would be monitored with a care that feels like tenderness. Oxygen sensors, humidity probes, and CO2 meters would be tucked among the vines. Algorithms and intuition would work together to keep the system near the sunlight sweet spot where plants thrive and people feel well. The farmer becomes an ecologist and a mechanic. The harvest is measured in kilograms and in comfort. Water in this system becomes poetry. It flows in loops through transpiration, condensation, and dew. It beads on cold surfaces and is led back to reservoirs. It carries nutrients like small boats, wending among roots and returning with stories of nitrate and phosphate and trace minerals. On Mars, almost every kilogram of water is a star player. Some comes from ice you melt and purify, some from the product of chemical reactions that make fuel, and some is recycled from air and waste that humans naturally produce. Closed-loop water systems on the International Space Station already recover most of what astronauts exhale and excrete. The sound of pumps and the smell of clean humidity would be familiar on Mars, with the difference that outside lies an ocean of frozen possibilities underfoot. Architecture expands like lichen. Early habitats might be inflatable modules covered by regolith. Later ones might be 3D printed from local materials, sintered into bricks by focused sunlight, or fused in ovens that eat dust and return structure. Where lava once flowed beneath a cooling crust, it sometimes left behind hollow tubes kilometers long. These lava tubes offer ready-made shelter, a cathedral of stone where radiation is an idea rather than a presence. Human rooms could nest inside, expanding gradually with each season. Lighting would create dawn and dusk under rock ceilings. Gardens would terrace along slopes. A child might ride a bike under basalt. Energy systems grow like roots in soil. Solar arrays extend across a gentle slope, with cables tucked under protective blankets. A kilopower fission unit hums nearby behind shielding, making steady kilowatts that keep life simple. Batteries recharge in the light and release that stored day in the quiet hours. Waste heat threads through pipes to warm rooms and water. The community maps its energy budget the way a village near the Arctic tracks firewood. There is a social rhythm to it. Washing happens when the sun is bright. Heavy science runs then. Stillness returns when the light lowers. It is not austerity. It is attention. Communication on Mars is patient conversation. Messages do not interrupt in real time. They arrive with the dignity of letters, carried by a dependable post, with the planet as the carrier. The gap is not lonely if it is expected. In the silence between send and receive, people write thoughtfully. They record voice notes and music. They compose small films of a day in the habitat. When replies arrive, the joy is not in immediacy, but in connection. There is a kind of mental health in that pace. Human nervous systems, often stirred by instant notifications on Earth, exhale. Ethics become structural elements, like beams you cannot see that hold the roof up. Planetary protection is one of those beams. Mars may be sterile today, but it is also possible that briny pockets below the surface hold microbes adapted to the slow drip of liquid water. It is possible that ancient rocks hold the chemical shapes of past life. When humans come, their microbiomes come with them. The goal is not to keep Mars pristine in a glass case. It is to explore with courtesy. Clean spacecraft where life detection is intended. Keep wastewater and organics contained. Study before you spread. Build in places far from special regions where liquid water might occasionally appear. Respect opens futures. It keeps science honest and keeps open the possibility of discovery that does not confuse our traces with another creature's. Terraforming often wanders into this conversation. A dream of making Mars more like Earth. The science at present is quiet about its limits. There is not enough carbon dioxide readily accessible to warm the planet significantly with current tools. Some proposals imagine producing strong greenhouse gases to thicken the air over long time scales, or placing a magnetic shield at a point in space to help Mars hold its atmosphere better. These are visions across centuries. They are interesting, but they do not guide daily design. What guides life now is the craft of habitable pockets. Think of coral reefs. They do not change the whole ocean. They create islands of abundance by patiently building with what is at hand. A Martian settlement is a reef of air and water in a sea of dust and stone. Geology becomes culture. People name rocks and gullies the way sailors name coves. They notice the seasons not just as dates, but as colors in the sky. The blue sunsets of Mars come when small dust particles scatter red light away and let blue sink straight through. Standing near a window during such a sunset might become a local ritual. You watch the blue fade back to brown, and you feel the roundness of time. Phobos rises and sets twice in a sol, a fast companion. Deimos moves deliberately. Children might learn their paths the way children on Earth learn the moon. The body adapts. Muscles learn new patterns. Bone responds slowly to reduced load. Exercise becomes a morning craft, not to chase records, but to keep joints singing and heart strong. Doctors and researchers monitor blood, eye health, vestibular function. They note changes and adjust routines. They consider questions that are still open, like how human reproduction proceeds in lower gravity, and they proceed carefully, with consent and caution braided together. A small community builds a medical culture of prevention, sharing responsibility for movement, sleep, and nutrition. Sound shapes the mind of a place. On Mars, the habitat hums at a gentle pitch. The greenhouse bubbles and sighs. Rovers click and whir when they return to charging bays. Outside is quieter, more padded. The thin air dulls echoes. The ground crunches. Inside, music becomes a shared language. A guitar sounds strangely rich in a pressurized room at a slightly lower total pressure, with carefully controlled humidity, strings singing against acoustics that love them. Stories become a kind of power, too. A person who has spent the day repairing a scrubber sits and listens to a friend read a novel. The lines of fiction ease the day. A song from Earth plays, and suddenly the habitat feels like a cabin in a familiar forest. In the broader view, living on Mars tells us something about Earth by contrast. The loops we perfect there shine a light on the loops we need here. Recycling air and water in a habitat makes the atmosphere of Earth feel like a gift too large to measure. Growing food under lamps makes sunlight on fields feel both sacred and free. Planning energy in dust teaches patience with weather at home. A settlement on Mars is not an escape from Earth. It is an education in loving it. In the quiet of the red planet, you can hear that truth clearly. If you close your eyes now and picture a neighborhood on Mars, you might see a cluster of rounded forms tucked into a shallow valley near the edge of an ancient delta. You might see a long greenhouse glowing faintly in the morning. A track lines the ground. It helps to ground the idea of living on Mars in a day that feels ordinary. The alarm sounds softly, a thermal chime that does not jar. You reach for a cup and pour water from a pitcher. The stream falls more slowly than you expect from a lifetime on Earth. It arches with gentle confidence. Beads separate reluctantly, and the surface of the tea ripples softly. You sweeten it with a spoonful that lands like moth wings. Small differences accumulate into a new normal, and with them comes a quiet delight. Your mind notices, smiles, and settles. You step into the light garden and harvest a handful of basil. The leaves are a green. It seems almost loud against a world of ochres and browns. The air is warm here and smells alive. A tomato when you pluck, it gives a small surrendering sound, and the skin is taut, ready to burst into taste that feels like summer no matter what the calendar says. In these rooms, the idea of food wraps itself around memory. It becomes more than calories. It becomes a living connection to everything you use to grow or buy on Earth. It becomes a promise that life here is not just survivable, but rich. Tasks unfold with the friendly logic of maintenance. Filters are rinsed. Sensors are checked. A rover's tire is inspected and dusted. A colleague reviews data from seismometers outside, listening to Mars's interior the way a doctor listens to a chest. The planet has quakes, small tremors, whispers of thermal contraction and tectonic relaxation. They arrive in the instruments like heartbeats in a stethoscope. This, too, is company. The world is not empty. It shifts, breathes, and responds to sun and shadow. Outside, during a short excursion, the sky feels large. Your suit behaves like a calm animal who makes sure you are safe. You move deliberately. You kneel by a rock whose surface has a crust of desert varnish, built slowly over ages by dust and chemistry. Your hand lens shows textures like tiny dunes. You label a sample, not for treasure, but for context. When you look up, the sun is small, the shadows are long, and your habitat sits as a gentle shape against a backdrop of weathered hills. Returning inside, you pause in the airlock and watch the dust drift in the small chamber. Mars dust is fine, like talc, and electrically clingy. Part of living here is learning to brush it away kindly, to keep equipment healthy and lungs clear. Good seals, decontamination routines, and patient design keep dust a companion rather than a threat. After a while, you become fluent in the ways it moves. You know when a storm has been through by the tastes of the air and the way light scatters. You know when a dust devil has tickled your habitat by the thin layer of fresh fine particles in places you brushed yesterday. In the afternoon, you exercise, not as a chore, but as a ritual that carries you back into balance. In 0.38 grams, your tendons learn new elasticities. Resistance machines and treadmills that pull harnesses against, you do the quiet work of reminding your bones the weight of a body they used to carry. You listen to music. You find a rhythm. You feel your breath deepen and your mood lift. The body and the mind are not separate here. They are partners in adaptation. As evening comes, lights dim on a curve. Circadian signals are woven into architecture with gentle skill. A window shows the world outside settling into its cool. The western sky edges toward blue. Someone sets plates on a table made from a composite of local fibers and imported resin, a material practical and charming. You eat and you talk. There is a shared language of the day. Small successes are celebrated. A leak caught early. A data set that shows a clear trend. A plant that decided to flower. In this setting, the mundane is beautiful. In the retelling, even tightening a bolt becomes a tiny epic, because it is tied to a bigger story of keeping a small human sea alive. Later, after messages have been sent to Earth and replies from a few days ago have been read and savored, you sit with a book. The pages are thin to save mass. The words are not heavy, or perhaps they are, with meaning rather than with ink. Sleep arrives like a friend, not like an obligation. Before you lie down, you glance at a photograph taped to the wall. A forest path. A family. A cat asleep on a window ledge. Home is not a place with one location. It is a collection of ties braided through time. On Mars, those ties feel more visible, like threads you can touch. If you are listening now in a soft chair, in a bed, on a bus, or in a kitchen where steam curls from a kettle, you may notice that Mars does not feel like a fantasy as much as it feels like an extension of something familiar. We already live inside protective shells full of loops. A house is a habitat that keeps weather at a respectful distance. A city is a network of energy and water and food and waste transformed and reused. On Mars, the skin of that system is simply thicker, the loops tighter, the attention more deliberate. The underlying idea is the same. It is care. It is willingness to keep each other well. The science is the armature that makes such care possible. The numbers here are gentle but firm. A habitat must hold pressure and limit radiation. A farm must return the right breath to the room. A power system must whisper along through dust and night. Each of these demands has an answer that is not romantic.